Okay, so today we're going to work on the surface area and volume of spheres. Okay, so the sphere, if you'd ever wanted to sketch a sphere, just draw a circle, and then when you're doing the sketch, all you have to do is do like a semicircle like this, and then another semicircle like that, dotted, and you can give the illusion of 3 dimensions. Okay, in the surface area and volume formulas, you just have to take them for granted. They're developed in the calculus course. So for us, we're just going to use them, and we don't care how we got it. We just want to use it properly. So surface area, 4 pi r squared, and volume, 4/3 pi r cubed. Okay? So in the calculator, for the volume, go 4 divide 3 in a bracket, then use the pi button, right, Abdur? Pi button, yeah. And then you can type in r power 3. The most common issue is they'll give you diameter, so always just chop that in half. So you get your radius of 4 meters. And to find the surface area and volume, you just plug into your calculator, okay? So go ahead and practice that now. And then do it yourself, okay? And then once you get the answers, look up at my screen and then see if you got the same thing. Okay, so I'm just using the formulas above. I'm plugging in, and I'm getting 201.06 for the surface area. Anybody disagree with that one? Okay. I'll get the volume one up for you. I've got like 268.08. You agree with that one, Phelan? Okay. Q button, not too many calculators have a Q button, so you have to use the power button, which on the TI is the hat looking thing. So your exponent button, guys, is right here. This hat thing. I don't know what this is called. Okay, and then if you have the calculators from me, it's this YX button on the right. YX. Okay, YX. Anybody have a calculator they're not sure how to get to the power button? Yep. 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 Oh, don't forget it's 4/3 with a divide. Okay, so any issues with calculators? Let's do the volume. 4/3 like that. Second here is pi. And then the radius was 4. And then power is here. And then the little hat. Yeah. Cool. Calculator issues. Four thirds. Second here. And then the radius was 4. Power 3. Cool. Okay, so let's do volume 4/3 like that using divide and brackets. And then second here for pi. And then the radius was 4. And then power 3. So 4/3 like that with the divide and brackets. And then pi is here, 4/3 pi. And then the radius was 4, right? And then here's the little hat, power 3. Okay? Yeah, right here, YX.
So the second?
Nope, just hit Y and then 3. Yx is your power. See y to the power x? Alright, so it looks like most people are getting comfortable with their chosen calculator. Thank you for being patient if you're already calculator savvy. These next two questions, they're not really related to spheres, but we'll do them anyway. So it says the area of a square room is 50 meters squared. So how could we translate that into a picture? Square room, just draw a square, and then what is 50 meters square? That's just the area of this 2D shape. Okay. So then it says, well, what is the length of one side of the room? So how do I get the side length from the area? Well, what's the formula for a square, for an area? Yeah, base times height, but it's the same. So what do we say? X times x, right? This is x. Because if it's a square, the sides are the same, so you can use the same letter, x times x. Okay. What is x times x? 2x, or is it x squared? X squared. Okay, so this 50, is it x or is it a? So substitute it in. Now how do I solve a square problem like this? Just like Pythagoras. Square root. And now you have the answer. Okay, square root 50. And then later in this course, we'll learn how to work with these radicals in a kind of nice way. It would look like this. This is a little snapshot of what it would look like. 50 is the same thing as 25 times 2. The square root of 25 is 5, and it becomes 5 root 2. That's some stuff we're going to do later in the course. Okay? So don't worry about this. But we'll do some of that stuff later. It's kind of fun. But all you need to worry about here is just, you know, what is the answer to the nearest centimeter? So square root 50, 7.07, so just 7 centimeters if it's rounded. Do you guys know how to find the square root feature on your calculator? Yeah, we did that in Pythagoras, right? Okay. Now the next one says if the trim on a circular tablecloth is whatever, what is the diameter? So what is the trim? Is it area or is it perimeter? It's perimeter. Okay, so I'll use my circle tool, and the trim, let's do a pink trim. Whoa, that's insane. That's not what I wanted. Let's go let's go with like one of those. That's a bit better. Not really, but you get the idea. So trim, if you see this, especially if English is your second language, trim is perimeter. So just jot that in. Trim is perimeter. And moreover, perimeter of a circle, what do we call that? Starts with a C. Circumference. So go ahead and locate the circumference formula. All the two-dimensional formulas are on the front, on the bottom. So what's the circumference formula for a circle? It says 2 pi r or pi d, whatever. You can choose either one. What are they looking for? Diameter. So let's just use the one that involves diameter. Circumference equals pi times diameter. And what did they give us? They gave us 3.5, which is the circumference. So put that in for C. And then how do we solve a problem for D like this? What do we have to do? Yeah, be confident. What is it? How do I solve for D here? Isolate D. Good. Divide by pi. So 3.5 divided by pi. Make sure you're using the pi button, or else we're all going to have different answers, okay? If Abdur uses 3.14 and Calvin uses 3.14159 and I use the pi button, we're all going to get different answers. So if everyone uses the pi button, then we're good. Don't use 3.14, use the pi button. Oh yeah, 1.114 is the diameter. So they want it to the nearest millimeter. So we have, because what did they give us? 3.5 what? Centimeters. So this answer is in centimeter. So if we want to convert to millimeter, we're going to have to times by 10. So we get 11.14 millimeter. And then they want nearest millimeter, so I'm going to round it to 11 millimeter. Okay? That's your final answer, 11 millimeter. This is times 10 here. Go from centimeter to millimeter, one jump, unit getting smaller, so our number gets bigger. Okay, so the next one here is volume of a sphere, and the volume is given. Do you remember that from last day, where the volume was given? What do you have to perform? Yeah, you must perform algebra. This is a very common theme in the first unit, is that they give you the volume, or if they give you the surface area, and they ask for one of the measurements, okay, whether it's length, width, radius, or whatever. So the volume of a sphere formula, jot it down, 4/3 pi r cube. They gave us the volume, so I substitute, where I see a V, I substitute 2500. And now I have 4/3 pi r cube here. Alright, now I'm going to show you how to do this calculation here on your calculator, okay? Actually, just calculate 4/3 pi and keep a few decimals. That's what we'll do. So what do we call this again? It starts with a C? No. For like an algebraic expression. Doesn't matter if it's measurement or Einstein's theory of relativity. What do we call this thing here in front of a variable? Coefficient. Okay? What do you always have to do to isolate a variable? Divide out a coefficient. Right now it looks really weird. So let's just find out what the number is for that. And we'll keep a few decimals for accuracy. That sound like a good plan? Okay, so 4 divides 3 times the pi button. Good. Good. 2500 equals 4.18879, like dot, whatever, right? R cube. Now it's more reasonable. What do I divide out now? The coefficient. Okay, so do that on both sides. And you'll isolate for r cube. So some of your calculators have an answer button on the bottom, so you don't have to retype everything. So that's a nice feature. If you're on the Texas Instruments calculator, all you have to do is go second and down here negative, and that will open up the answer button, which is the answer from the last calculation. So it like copies and pastes it. And in fact, if you have one of these nice calculators, you can actually just scroll up using the up arrow, and if you press enter, it will like copy and paste it to the next line. So that's a nice feature as well. Okay, so I have this 4.188 whatever stored in my calculator. I'm going to go 2500 divided by answer, and I got 596.831 blah blah blah. Now just like in Pythagoras, when we want to take the square root of a square, this one, because it's cube, we have to take the cube root. Okay, and on different calculators this is going to have different features, okay? So cube root both sides. and then you will solve for r. So I'm looking for the cube root of the answer. Okay? And I'm going to pause the video here because I know some people are going to have calculator issues here. Okay, so draw a cube, and then we're going to try and figure out the length of one side. So draw a square. Oh, we're having issues. Okay, so here we go. Draw your cube. And you already know the answer? How do you solve for the answer here? Cube root, good. So just like for the square, it was square root. Now you have to do cube root. So this 720 cubic centimeters is the space inside here. Okay, so in order to find the space inside, we have to cube root, and that will give us x. Okay, because volume of a cube is x cubed. They gave us 720, and then in order to solve an equation like this, we cube root. Cube roots cancel the power, and cube root 720. And some of you should know how to do this now, since we just spent some time on the calculator, and I got like 8.96. And that unit's going to be centimeter, and yet you can round it however you like. All right, now the next one is about the moon. I was reading something cool on the internet about the moon. The guys who were up there, they left their footprints in the moon, and because there's no atmosphere, no wind, that footprint is always going to be there. That's pretty interesting. Do you have a question? You may use the washroom. Can you just wait like 2 minutes? We're almost done. Like 5 minutes. Okay, so the moon approximates a sphere with diameter 2160 miles. What is the approximate volume? Okay, this is too easy. All you have to do is divide this by 2 to get the radius. I got 1080. 1080. And then volume of a moon, so volume of a sphere, 4/3 pi r cubed. R is 1080. Yeah, it's a really big number. Obviously, the volume of the moon would be quite large. Yeah, so like those of you who are on a calculator that you're not familiar with, like the one that I let you borrow, it puts little commas at the top every 3 digits. That helps you determine, like, is it 1,000, million, whatever it is, right? So my calculator is writing this: 5,276, 669, 286. And there's no decimal. Okay, which is weird. Maybe I just ran out of space on my calculator. Did you get something similar to this? What's the decimal? The other people have 0.8 at the end? Yeah, my calculator must have run out of space. Yours went to scientific notation?
But it didn't bother putting a decimal.
Oh, you're no decimal either. Okay. So, how do we read this number? So, this is 1,000, right? This is 100,000. No, careful, careful. 1,000. What's 1,000,000? So this 6 right here, that is a million. Good. And then this one is our billion. So this is 5 billion. Okay, 276,669,286 miles cube. Delicious. I like that answer. Unless the moon is, they know it's not hollow. Okay, the next thing is hemisphere. Now, for the hemisphere, if you got some space above, okay, I'm just going to draw a little diagram for the hemisphere, and then a little bit of notes for the hemisphere. Oh, get a P in there, hemisphere. Okay. So, if you take a sphere and lop it in half, see you later. Boom. Right? You have this dome shape. Okay, so let's just draw it like this, and like this, and like this. It's this dome shape. It's like a dome. Okay. Now, let's take a look at what happens. I just erased it. I'm running out of space. So the volume formula, the 4/3 pi r cubed. What do you think the volume of half a sphere would be in terms of the normal volume? Yeah, just divide by 2. Okay. So dividing by 2 is similar to timesing by 1/2. Timesing by a half is the same as dividing by 2. Do you agree with that? Okay. Now I can put the coefficients 1/2 and 4/3 together. Okay. So what's 4/3 times 1/2? 4 times 1 is 4. 3 times 2 is 6. So 4/6 pi r cubed. What does 4/6 reduce to? 2/3 pi r cubed. Is this guy on your formula sheet for hemisphere of a volume? It is there. Okay. Now, let's talk about the surface. That one's pretty simple. It's just half the space. Half the space, and then we just merged a couple fractions there. But the surface area is a different beast on its own. So, for a sphere, it's 4 pi r squared. Do you agree? So then if you chop the sphere in half, you should do just like you did above. You should divide by 2 for the hemisphere, right? So what's this 4 pi r squared divided by 2 going to be? Yeah, just 2 pi r squared. You can merge the coefficients, 4 and a divide by 2. Or 4 times a half, whatever you want to do it. However, and I'll get to you in a second, Bailey, when you chop a sphere in half, what do you introduce on the bottom? A new face. And what type of shape is that on the bottom? A circle. What's the area of a circle? Pi r square. So you have to add another pi r square to get 3 pi r square. That answer your question? So on your formula sheet, you have the hemisphere formula for the entire shape. If they ask for the lateral surface area of a sphere, or pardon me, of a hemisphere, you have to use the 2 pi r square. Does that make sense? Lateral surface area of hemisphere, you have to use the 2 pi r square. Okay, so I'm glad I got to that. Now all we have to do is number 7, and then you have plenty of time for homework, so you can get that done in class. Remember, next Wednesday, first exam. Today is the 10th. So exactly a week from today. Okay. All right, so let's jump into 7. What is the surface area of a hemisphere to the nearest tenth of a square centimeter if the radius is 5? 4 pi r square. 4 pi 5 square. Oh, my bad. Thank you. I literally just talked about that. It is definitely 3. Okay, 3 pi r square. And in terms of like a super math way to express your answer, this is called what they call an exact value. This is for all the math nerds in the room. You can just keep the coefficient and the pi together. So 5 squared is 25 times 3 is 75. So 75 pi. Okay. In a pure math sense, that's how you'd want to leave your answer. And then any approximation, like a nearest tenth, you can just type in 75 pi, and you can get your approximation. To the nearest tenth would be 235.6 centimeters square. Okay, so like in a calculus course, you would want to leave your answer as 75 pi. In 10C, this 235.6 is perfect. Okay. The next thing is the volume. I think it was 2/3, right? Pi r cube. So 2/3 pi, what's r? 5 cube. Can you guys do 5 cube in your head? 5 times 5 times 5? Nope. 5 times 5, 25, and then you need 5 more groups of 25. 125, good, Phelan. 125 times 2, 250 divided by 3 is not a perfect division, so we'll leave it like that. 250 divided by 3 pi. There's your exact value. Or you could just type it in right from the get-go and get your decimal answer. Okay, which I'll do. 2/3 pi times 5 to the power 3. I got 261.8. You guys agree? Okay, centimeter cube. Just make sure you got your correct units, square units versus cube units. And the last question, what happens to the volume of a sphere when the radius is doubled? Oh, this is a completely different question. It's question 8. What happens to the volume of a sphere when the radius is doubled? This sounds like a physics question. This is like a physics 20 question. I wonder if it's going to be on your test. Okay, let's just jot down the formula for the volume of a sphere. 4/3 pi r cubed. So that's the volume of a sphere. We've taken care of that. Now what does it mean to double a radius? What does r become? If the radius is doubled. R becomes, yeah, it is the diameter, but what would r become if you double it? Not squared. Just 2r. Very nice. 2r. Okay, so we have to do a substitution here. Substitution of r for 2r. And when we do substitutions, you always put a bracket. So r became 2r. And then if you remember back to grade 9, what happens when you have a product like a times b to some power x? That power has to be applied to both. Do you remember that? So this 3 has to be applied, this power 3 has to be applied to both. So you have a 2 cube and you have a r cube. Okay, so I'm just going to highlight the original question or the original formula. And now I'm going to highlight this new formula. What's the only thing that's different? The 2 cubed. What is 2 cubed? 2 times 2 times 2 is 8. So it's 8 times 4/3 pi r cubed. That 4/3 pi r cubed was the original volume. 2 cubed is 2 times 2 times 2, yeah. You're basically just putting an 8 in the front, which is times. So it's just 8 times the original volume. So what happens to the volume of a sphere if the radius is doubled? The volume gets times by 8. Okay, that's a tough question. And that's they do these types of questions in like physics 20. They'll be like, okay, if the radius or if the distance between two bodies of mass is doubled, what happens to the force of gravity? Stuff like that. Okay, and this is a physics 20 question. I don't usually see this in math 10. Okay, but like always, at the bottom of every page or every assignment, every section, there is an assignment. Okay, and every assignment gets recorded in your homework. Okay, so you have 20 minutes or so. 5, 10, 15, 20 minutes. Yeah, go use the washroom. So you have 20 minutes to finish this assignment and get help.